So the general form in which we define an algebraic data type is as follows. So you start with the keyword data type, then the name equal to constructor 1. There are two options here. You can either have a just a constructor 1, or you can have constructor 2 of some type. Okay, and these can be polymorphic. So let's say we can have some type variables to begin with. Okay, yeah, this is how the a general form of a data type will look like. Okay, so the constructors can be just the name of the constructor, or it can be constructor of is a keyword and some type, and this type can refer to these type variables actual. Okay, so one constructors are of two forms, either just C1 just C1 or something like C2 of some type. Okay, this is the case, and these some types, the types appearing on the RHS can refer to the type variables in the LHS. In this case, code A, code B, or code C. Okay. And third, the type can be recursive. So some type, that is some type, can refer to name itself. Okay, so this is the general form in which these data types are declared. Okay, the result of defining this data type is two things. The consequence of a data type definition is like one, a new polymorphic type name C. This type is created. Okay, second thing is constructors becomes functions. Okay, so in this example, in the example above, we have C1 is of type A, B, C name. C2 is of type some type to A, B, C name, and C3 is similar. Okay, this kind of thing. Okay, the sum type becomes an, so whenever you have a constructor of the kind C of something, C becomes a constructor of type something arrow, the name, the type that is defined. Okay, so that is how the general form is. Okay, and But the constructors are not just arbitrary functions. They can be used in pattern matching. That is the important thing. Okay. So third, sorry, constructors can be used in pattern matching involving values of the type name. Okay, so that's kind of clear, and that's the overall idea. So a pattern can be variable underscore and all those kind of things, and it can also be C1, for example, okay, or C2 of some pattern. Okay, so it can be, that is in this case uh, patterns are extended with C1 is a pattern, C2 P is a pattern. So let me write it as a 3 steps of this. C1 is a pattern of type second. C2 is a pattern. C2 if P is a pattern. If P is a pattern type something, and then C2P is also a pattern. And the pattern matching rules are the same as we defined. I mean, it will try to reduce the value and check whether it matches this constructor or that constructor. Okay, so this is the overall idea behind how data types are defined, algebraic data types are defined, and how their pattern matching and values are constructed. Okay, and the tree example, the list, the option example that we saw are special cases of this.